going on, guys? Let's look at this problem right here. This question is asking a DC series motor operates at 750 revolutions per minute with a line current of 100 ampere from the 240 voltage mains. Its armature resistance is 0.15 ohm and its series field resistance is 0.15 ohm. Assuming that the flux corresponding to a current of 25 ampere is 50% of that corresponding to a current of 100 ampere, determine the motor speed at a line current of 25 ampere at 240 voltage. Here Vt is equal to 240 and I line, which is equal to Ia1, that is equal to 100 ampere, and Ra is equal to 0.15, that's armature current, and series current is 0.15 ohm. First we had to find out the Ea1. Ea1 is basically Vt minus Ia1 times Ra plus Rc. Here Vt is given to be 240 voltage, 240, and the current is given to be 100 ampere, 100, and the armature resistance is 0.15, and the series resistance also 0.15. 0.15 plus 0.15, and if you calculate this one, you're going to get 210 voltage. This is Ea1. Now we have the line current, second line current, that is Ia2, 25 ampere, 25 ampere, and that one also 240 voltage. So we can calculate Ea2. Ea2 is same formula, Vt minus Ia2 times Ra plus Rc. Vt remains the same, 240 minus Ia2 is 25 ampere, 25, and this armature resistance and series resistance are same thing, 0.15 plus 0.15, and that gives us 232.5 voltage. And here we had to know one thing, that is E, and the speed is directly proportional. So the equation will be like this: E2 over N2 is equal to E1 over N1. Now here we have the first speed provided, that is N1. Okay, and actually I put the formula wrong. E2 over E1 is equal to N2 over N1 because it's directly proportional. So if E2 upside, N2 has to be upside as well. E1 is downside, N1 has to be downside as well. Okay, N1 is given to be 750 revolutions per minute. Here our purpose is to find out N2, and also here we have to consider phi as well. Phi is the flux, because when we don't have flux we can directly plug it, but if we have the flux given, we had to consider that one as well. Okay, so for the flux corresponding 100 ampere is phi, and here they are saying assuming that the flux corresponding to 25 ampere is 50% of the corresponding current 100 ampere. It means for 25 ampere it's half of that. So phi 1 is equal to phi, then phi 2 is equal to half of phi divided by 2. That's another thing to consider. Here phi 2 divided by phi 1. Okay, now here our purpose is to find out the N2. N2 is equal to, okay, let's simplify this one. Instead of phi 2 and phi 1, E2 over E1 is equal to N2 over N1. Instead of phi 2, I put phi by 2 divided by phi 1. Phi. Okay, here phi cancels and we will get 1 over 2, and we are trying to find out N2. N2 is equal to E2 over E1, or let's put Ea2 over Ea1 because that's the name we used right there. EA2 over EA1 multiply by 2 and also N1, 2N1. I brought this 2 from the denominator. This 2 is in the denominator. So when we bring to the other side, it's going to be in the numerator. And N1 is in the denominator. So when we bring it to the other side, it's going to be in the numerator. Now EA2 is 232.5 voltage divided by EA1, that is 210 voltage, multiply by 2 times N1, that is speed 750 revolutions per minute. And when we calculate, this one is going to give us 1660.71 revolutions per minute. And that is the N2 speed. And that's how we do this kind of problems. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn electromechanical system, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.